Okay, this is a spring break review for you guys. This is just to get you caught up a little bit, make sure you understand all the things we've done first semester. Just a nice little way to get some skills going over spring break. I'll also give you some extra credit points for completing this. So the plan is for you to watch the video and then pause it and do all the problems on a separate sheet of loose leaf. So you're going to need pen or pencil and a sheet of loose leaf because you're going to be doing quite a few problems here. I'll explain how to do the problems and then you'll do the problems and then move on. We are going to start with a review of fractions. So we're going to start on this slide with adding and subtracting fractions, and I'm just going to do a random example for you. So if we throw out like 3/7 minus 2/5, the first thing we need to remember is that we need to get a common denominator. So we have to find the least common denominator between 7 and 5. And the least common denominator between 7 and 5 is going to be 35. That's the smallest number that both 7 and 5 can multiply into. So we're going to have to take the fraction on the left and multiply by 5 over 5, which is the equivalent of 1. And the fraction on the right, we're going to multiply by 7 over 7. So what that's going to do for us, 5 times 3 is 15, so we have 15 35ths, minus 2 times 7 is 14, in the numerator 14 35ths. And then remember, when we add or subtract, we don't do anything to the denominator. Leave the denominator alone, and we just add or subtract the numerator. So 15 minus 14 is 1, and so we have an answer there of 1/35. Notice numbers 4, 5, and 6 look a little bit different. Number 4, you have 5, but that's really the equivalent of 5 over 1, so you can multiply the 5 by 7 over 7 to solve that one. Number 5, 2 and 4/5, the best recommendation I have, and I'm going to write up here in the corner, if you have 2 and 4/5, let's change that from a mixed number to an improper fraction. So you're going to multiply 2 times 5, which is 10, and then you're going to add 4, so you're going to get 14/5. So in problem number 5, you're really going to take 14/5 plus 3/7. Same thing with number 6. You're going to want to change 1 2/5 to 7/5 before you get your common denominator and subtract. So on a sheet of loose leaf, I want you to pause the video and I want you to do these first 6 problems. Next on the agenda is multiplying and dividing fractions. So if I just get a random problem up here, let's say we have 3/5 times 8/9. Okay, the rules for multiplying fractions, we simply multiply the numerators and multiply the denominators, and then at some point we want to simplify. Now the easiest thing to do is simplify right away. So really the reason we can do that is because this is 3 times 8 over 5 times 9, and we can multiply and divide in any order we want. That's why it's legal for me to cross out the 3 and cross out the 9 and reduce that to 1/3. And so when we multiply across the numerator, 1 times 8 is 8, and the denominator, 5 times 3, is 15. So our answer is 8/15. Okay, for division, let me get another problem up here. For division, if I have something like 6/5 divided by 1/15, remember what our rules are. We are going to multiply by the reciprocal, or as I've commonly said throughout the year, copy dot flip. In other words, I'm going to copy the 6/5, dot means multiply, and then flip 1 over 15 to 15 over 1. And then, just like I did in the previous problem, I can simplify. 15 over 5 is the equivalent of 3 over 1. Multiply 6 times 3, 18. 1 times 1 on the bottom is just 1. So we get 18 over 1, which of course is just 18. Now looking at the problems below, 7 through 12, the only ones that you might have a little bit of an issue with would maybe be 9 and 12, because again, I've given you a couple mixed numbers. You need to change those to improper fractions before you multiply or divide. So go ahead and pause the video and do numbers 7 through 12. Next up we have order of operations. Remember what we talked about when we did order of operations was PEMDAS. Our acronym stands for parentheses, exponents, multiplication, division, add, and subtract in that order. So as an example, let's take a look at something like 12 plus 6 times 3 minus the quantity 6 plus 10. We want to simplify that. And of course, following order of operations, we're going to want to do what's in parentheses first. So we're going to add 6 plus 10, and then we're going to have 12 plus 6 times 3 minus 16. And then order of operation tells us that we need to do multiplication before addition or subtraction. So we're going to have 12 plus 18 minus 16. And of course, addition and subtraction we need to do from left to right. So we're going to do 12 plus 18 first, 30 minus 16, and our final answer here is 14. So again, I'd like you to pause the video and do the next, looks like 8 problems here, and we'll move on after you're done. As we move through semester 1, we talked about adding, subtracting, multiplying, and dividing positive and negative numbers. Now there's multiple examples that are on this PowerPoint slide, and a couple problems to note. A problem like 21, notice how the negative number is bigger than the positive. So in 21, we would expect a negative result. In other words, 16 minus 18, we are going to get a negative 2 result. In number 22, notice how the positive number is bigger than the negative. So in essence, we're really taking 11 minus 6, which is 5. And 23 is also of note. If we have a negative number, negative 8 minus 13, our answer is going to be a larger negative. And in other words, negative 8 minus 13, really we're going to add the 13 and 8 together and get a larger negative. Negative 21 would be our answer for number 23. And then of course 24, problem like 24, we are subtracting a negative number. Remember, when we subtract a negative number, it's really like we are adding. So this is going to be negative 3 plus 5 or 5 minus 3, which is of course an answer of 2. And I'll let you continue on. It's also great practice here. Notice 27, 28, and 29. You have to combine what you know with our fractions with what we have learned about adding and subtracting negative numbers. Same thing in problems 30 through 35. It's multiplication and division problems. You should be able to do all of those as well. So just as one last example here, we'll do number 28 together. 2/7 minus negative 1/2. So I'll just do it over here on the right side. 2/7 minus a negative is actually going to be like adding 1/2. And of course we need to get a common denominator there. So I'm going to multiply the left fraction by 2 over 2. So I'm going to get 4/14 plus, and in the 1/2 I'm going to have to multiply that by 7 over 7. So we're going to take 4/14 plus 7/14, and our final answer, 4 plus 7 is 11. 11/14 is the answer to number 28. So you can go ahead and pause the video and finish up these problems and then move on. There's a couple things I really want to make sure we understand when we are solving these simple equations. The first thing is we talked about reverse order of operations. We're not following PEMDAS to solve these equations. For example, we'll do number 36 together. 2x plus 15 equals 51. We would not divide before subtracting in this problem. In other words, some guys would divide the whole equation by 2. I've seen that mistake plenty of times. That's not correct. Reverse order of operations tells us we have to get rid of the 15 first because of course we're trying to isolate x, and then the reason I subtracted 15 is because positive 15 minus 15 is 0, and we're one step closer to isolating our x. Now we have 2x equals 36. And then we can divide both sides by 2, and of course x equals 18. That's the answer to number 36. Now 37 is a little bit different. You're going to subtract the 18, and then we have to isolate our x, so we're going to have to divide both sides by -1. So 37, you're going to subtract 18 and then divide by -1. The next problem I'm really interested in is 38. I'm not going to do it for you, but real quick I'll talk about it. Before we can do anything else in number 38, we're going to have to distribute that negative sign. And then remember, we're going to get all the x's on one side of our equation, all the constants on the other side of the equation, and then we can solve. Problem like number 39, I see a ton of mistakes. Negative 12 equals 3/4 x. There's a fraction in front of our variable. A lot of guys aren't sure what to do. What you should do is multiply by the reciprocal. Now remember, whatever you do on the right side of an equation, you have to do on the other side of the equation as well. So if I multiply by 4/3 on the right, I have to multiply by 4/3 on the left. The reason I multiply by the reciprocal is because 4/4 reduces to 1, 3/3 reduces to 1, and I am left with x isolated. And so I just need to take 4/3 times a negative 12 to find my answer. 12/3 reduces to 4. 4 times negative 4, my answer is negative 16. Looking at some of these other problems, we have a few tough ones on there. We can look at maybe a problem like number 43. We'll look at 43 together and then you can solve the rest on your own. So in number 43, again, the distribution is really, really important. So we're going to get 2 minus x plus 4. Remember, a negative times a negative is a positive, and that is going to equal 3x plus 5. Next, we have to get all our x's on one side of the equation. So I'm going to add x to both sides and combine terms. So I'm going to do a couple things at once. I'm going to add the 2 and the 4 together to get 6, and that equals 4x plus 5. And then, of course, I need to subtract 5 because, like I said earlier, we have to get all the x's on one side of the equation and then all the constants on the other. So 4x is going to equal 1. Since I'm running out of room, I'm going to write this above here. 4x equals 1. Divide both sides by 4, and we get x equals 1/4. So that's a fairly difficult problem. And a problem like 47, that's the last one I'll talk about here. If you want to make 47 a lot easier, you can multiply the entire equation by the least common denominator, 6. And what that'll do for you is it'll get rid of all the denominators, so you don't have to work with any fractions. That'll make that problem a lot easier. You can do the same thing with number 46 if you so choose. If you don't like dealing with fractions, it makes the problem a lot easier. So go ahead and continue on with 36 through 47 on your loose leaf. Pause the video and then we'll move on. Factoring is going to be really important here in the fourth quarter. We're going to go back to doing a lot of factoring, so you really need to understand how to factor and the different types of factoring problems. Now notice the difference between a problem like 48 and a problem like 52. Notice in 48 there's only 2 terms. 49 there's only 2 terms. If there are only 2 terms, then your only options to factor, you are either going to have a GCF problem, a greatest common factoring problem, or a difference of squares problems. Now, a GCF would be something like this. If we had 4x cubed minus 16x, remember the greatest common factor is the biggest number that is a factor of both our terms. In other words, 4 and 16, the number 4 goes into both 4 and 16. X goes into both x cubed and x. So our GCF here is 4x. Now, we start our parentheses and we're going to divide both terms by 4x. So when I take 4x cubed divided by 4x, the 4's cancel. X cubed over x is x to the second, minus 16 divided by 4 is 4, and the x cancels. So we're left with x squared minus 4. Now this one I have to be a little bit careful because the x squared minus 4 can be factored as a difference of squares. How did I know that? Because x squared is a perfect square, 4 is a perfect square, and there's a minus sign. So I can actually factor this x squared minus 4 into x plus 2 times x minus 2. And this would be our final answer. Now, if there's a problem that has 3 terms in it, like number 52, we call that a quadratic. We are going to get our 2 sets of parentheses and start with an x and an x, because x times x gives us x squared. And then we're going to focus on the 8. What factors or what numbers multiply together to give you 8 that also add up to 6? 4 times 2 is 8. And if you take positive 4 plus 2, you get your 6 in the middle. Signs are really, really important, so we factor x squared plus 6x plus 8 into x plus 4, x plus 2. Now, a problem like 53, notice how the signage is different. You have a negative 5x in the middle. So we're going to get our x and our x. What numbers multiply to give us 6 that add up to negative 5? 3 and 2 multiply to 6. Of course, the signs are going to be negative, because negative 3 minus 5 and minus 2 gives us a negative 5. So that's the difference with our signs. Problem like 55, on the other hand, notice how the last term, 32, is negative. So the only way we can get a negative 32 is by multiplying a positive number and a negative number. So I know for sure that we're going to have x plus, x minus. What numbers multiply to 32 that add up to a negative 4? 8 times 4 is 32. But you have to be careful. Is it going to go x plus 8, x minus 4, or is it going to go x plus 4, x minus 8? We look at the middle term, negative 4. So the bigger number has to be negative, the 8. So x plus 4, x minus 8 is our answer. Alright, now just a couple hints on this rest of this slide. If you do a problem like number 50, it's a double factoring type problem. In other words, you have to GCF first. So I'm looking at number 50. You have to GCF first, and then it may be that you can factor again. Alright? As we move along, last one I'll cover is a problem like number 58. 58 is a tough problem. And the reason it's a tough problem is because of the 2x squared at the beginning. The only way we can get 2x squared is by multiplying 2x times x. And it's more difficult because what factors of 15 add up to 13 isn't exactly accurate. The factors of 15 are 5 and 3 or 1 and 15. But what happens is when we break down 5 and 3, when we FOIL this, 2x times x is 2x squared. 2x times 5 actually gives us a 10x, and then plus 3x gives us our middle term of 13x. So I actually have put the proper numbers in here. The method I used was guess and check. I used a logical approach. Now there's another method I showed you in your notes that you could use, but I think our best option for right now is the guess and check option. So that's when you're going to do problem number 59. You're going to start with a 3x and an x, and I'll let you fill in the rest of that to factor. Number 60 looks like a GCF problem, and you will also, on number 60, factor that as a difference of squares. And I'll let you go ahead and knock out 48 through 61. The next topic we have here is solving equations by factoring. Remember, the most important thing we talked about when we solved equations by factoring, we have to set one side of the equation equal to 0. So in number 63, we have some work to do. Before we do anything else, we would have to add 20 to both sides to set the equation equal to 0. Cannot factor until you set one side of the equation equal to 0. So you're going to have to do some extra work in number 65 and 67 as well. Once you set one side equal to 0, I'll just take number 62 as our example. X squared minus 13x plus 12 equals 0. And I'm going to factor that. Factor that into x minus 12, x minus 1 equal to 0. Now, x minus 12 I'm going to set equal to 0, and x minus 1 I am also going to set equal to 0, and we're going to get two answers here. So in the first equation, I'm going to add 12 to both sides, and my first answer, x equals 12. My second answer is going to be found by adding 1 in the second equation. My second answer is x equals 1. So I'm going to go ahead and circle that. Those are my two answers. Go ahead and you go find the answer to 62 through 67. Now we're going to move into some second semester material. One of the first things we did in the second semester was find slope. And we had a formula for finding slope, and the formula said y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1 was going to give us our slope. So in a problem like 68, we'll go ahead and work 68 together. In a problem like 68, remember, 2 comma 2, those 2 points are x sub 1, y sub 1. 6 comma 8, that's our second x coordinate and second y coordinate. That's where the x sub 2, y sub 2 comes from. So if I plug these numbers into my formula correctly, I'm going to take y sub 2, which is 8, minus y sub 1, which is 2, and divide that by x sub 2, which is 6, minus x sub 1, which is 2. And I get 8 minus 2, which is 6, divided by 4, and that reduces to 3/2. My slope is equal to 3/2. Now the biggest mistake guys will have is subtracting negative numbers or working with negative numbers in general. So in problem 69, you have to be very careful because we're going to take 4 minus a negative 3 in the numerator, which is 7. So you have to be really careful with your signs here, and I'll let you finish up the last two on your own. Standard form, I gave you a handful of rules. Standard form is given as ax plus by equals c. And the rules I gave you were x and y have to be positive coefficients, and we cannot have fractions. So we'll look at number 72 together. So in number 72, we have a fraction, 4/5. So the very first thing I would do in number 72 is multiply by 5, so we don't have any fractions. And I'm going to distribute the 5, and we're going to get 5y equals 4/5 times 5. The 5's cancel. We get 4x plus 8 times 5, which is 40. Now remember, x has to be positive. So what I'm going to do is I'm going to subtract 5y from both sides and subtract 40 from both sides. And in essence, what this will do, this will give me negative 40 equals 4x minus 5y. And I have a positive x value, 4x, and I have no fractions, and I have x and y on the same side of my equation, which is exactly what we want. So I'm just going to rearrange this. I'm going to switch the 4x minus 5y, so that's on the left side, equals the negative 40 on the right side. So this would be our final answer for number 72. And I'll let you work 71 and 73 on your own, get all three of those problems on your loose leaf, and we're good to go. Here we have some graphing that we want to do. Remember, to graph, there's multiple ways to graph, but the easiest way for us is going to be putting our equations into y equals mx plus b form. In other words, we want to isolate y, and we want to get our x's on the right side of the equation and our constants also on the right side of the equation. So I'm just going to do number 74, and we're going to subtract 4x from both sides, and then we have 12y equals negative 4x minus 24. And again, to isolate that y, we're going to have to divide both sides by 12. So we end up with y equals 4 over 12 is 1/3, so it's a negative 1/3 x minus 2. Negative 24 divided by 12 is negative 2. So now we are in slope-intercept form. And we're going to get a graph going with our x and y axes. And remember, the first point is going to be where our y-intercept is. And the reason we always start here is because it's the easiest point to start with, meaning if I say x equals 0, any number times 0 is going to give us 0. So in essence, the 1/3 times 0 is going to go away, and we have y equals -2. So that means we have a point at 0, -2. 0 being our x-coordinate, -2 being our y-coordinate. So my first point is going to be right here at 0, -2. Now the next part of importance is our slope of -1/3. Remember, slope is rise over run. So the rise is going to be -1, and the run is going to be 3. So we're going to go down 1 and right 3. So down 1, right 3 is this point. Or we can go a slope of 1 over -3. That's the same as -1/3. And instead of going down 1, we're going to go up 1 and left 3, which would be the point here. And when we connect those points, it's tough for me to do on this lesson. It's not a great looking line, but you get the point. That would be the answer to graphing this particular equation. Now you guys finish up 75 and 76. Last chapter we did, chapter 8, we talked about solving systems of equations. The first way we solved systems was through substitution. And our rules of substitution, number 1, was to isolate a variable. So I'm going to look at problem number 78 here. And in the equation x plus y equals -3, I am going to subtract y from both sides in order to get our x variable all by itself. So x equals -y minus 3. And what I'm going to do is I'm going to substitute that x into our second equation. And what that'll do, and I'm going to rewrite this second equation, but instead of writing 2x, I'm going to write 2 times -y minus 3, because x is equivalent to -y minus 3. And then I'm going to continue to write the entire equation, so I still need my -3y or minus 3y equal to 4. And what this allows us to do is solve, because now we have only one equation with one variable. And so I'm just going to solve like I did in semester 1. We get -2y minus 6 minus 3y equals 4. Combine like terms. -5y minus 6 equals 4. I need to add 6 to both sides. And -5y equals 10. Divide by -5. Y equals -2. Now the good news is when I use substitution, once I find my first variable, in this case y, it's really easy to find my x. All I have to do is take this equation up here that I'm just circling, x equals -y minus 3, and I'm going to plug in -2 for y to solve for x. So x equals -2 minus 3. You have to be really careful with our signage here. Notice there's a negative in front of the y, so it's a minus a -2 minus 3, so x equals +2 minus 3, or x equals -1. And we write our answers here as ordered pairs. So I'm going to write my answer as -1, comma, -2. That's my final answer. And you guys can go ahead and solve 77, copy down 78, and get 79 done as well, and then we'll move on. On to the last slide here. We're going to solve systems by using what we call the elimination method. Now remember, for using the elimination method, we're trying to get the coefficients in front of one variable to be opposite. Now in number 80, that's already done for us because we have a -2 in front of the y and a +2 in front of the y in the second equation. So when we add those two equations together, we get 4x equals 20. Now, that's pretty easy in problem number 80, but it's a little bit more difficult in problems 81 and 82. In problem number 81, we're going to have to subtract 2x from both sides so that we have our x's, our y's, our equal sign, and their constants. In other words, we have our equation in standard form. Now in number 82, we already have our equations in standard form, but we have a problem. We have coefficients of 2 and 3 in front of x, and negative 3 and 5 in front of y. Those are not opposite coefficients. So what we need to do is we need to multiply the top equation by 5 and the bottom equation by 3, and what that will do is it will give us a negative 15y and a positive 15y that will cancel out. And so I will have opposite coefficients, and I will be able to solve by using the elimination method. So what I'm going to do is I'm going to distribute the 5, and I'm going to write this above. So I have 10x minus 15y equals negative 125 in my first equation. In my second equation, when I distribute 3, I get 9x plus 15y equals 30. And now when I add the two equations together, which is my next part to elimination, I get 19x, negative 15y plus 15y cancels out, equals negative 95. Now I can divide both sides by 19, and I know that 5 times 20 is 100, so I know when I divide here, x is going to equal negative 5. 95 divided by 19 is going to give me 5, so x equals negative 5. Now I need to find my y value. Now in order to find my y value, I'm going to use substitution. I'm going to substitute x equals negative 5 into an equation. I am going to choose the equation 2x minus 3y equals negative 25. And what I'm going to do is I'm going to replace the x with a negative 5. So 2 times negative 5 minus 3y equals negative 25. Negative 10 minus 3y equals negative 25. I'm going to add 10 to both sides, and negative 3y is equal to negative 15. When I divide by negative 3, I get y equals 5. So that gives me my ordered pair solution. My final answer, which I'm going to write in parentheses in x comma y form, negative 5 comma 5. Remember, x comma y is the correct way to write our answers. And so this concludes our review. Get these last 3 problems on your sheet of loose leaf, ready to roll and turned in for your extra credit points.